Alright guys, so I wanted to record this because you will definitely need to watch this video for use up. But I want to mention some things before I start class today. The aftershocks of me being absent that one day should be over. Okay? By today they should be over. And what I mean by that is I started putting grades in the grade book, and as soon as the zeros went in, people started coming in, oh, what can I do to, you know what I mean? You know what I'm talking about. Be honest, raise your hand if you're ready to turn this in today. That's amazing, and that's outstanding. So here's what I'll say. Those of you who did this homework that I repeatedly reminded you about, just to make sure that you did the homework from home, please make sure that you're watching the calendar, that you're actually reading the calendar to know what's due when, okay? If you turn this in today, I will give you an extra 10 points as far as whatever grade you get, okay? An extra 10 points. If you turn it in next class, it will be still full credit. The one after that will be, I won't accept it. Like no late grade on this. Okay? It should be late the next class you turn it in, but it seems like a lot of you didn't know about this assignment. Even though we did it in class, I told you there would be a homework assignment, I just did not print this out and give it to you. I said, print it off at home. Okay? Here's what I'll say. No worries. If it was my bad, if it was yours, regardless of what it is, I think the aftershocks are settled. Okay? So make sure, please, that you do not procrastinate to turn this one in, because I will not accept this one late. Okay, the next time will just be for full credit. Okay, those of you who are ready to turn it in today, if you understood what you did, turn it in. It'll be for 10 more points that you'll get, so I'll put 110. If you didn't understand, you still have the weekend to do it to make sure that you're understanding. Okay, go to these videos, and I believe it's part 2. You have to watch that one that we did together, okay? The one that we did together is huge to help you with this homework. Okay, please don't blow this homework up. Don't dismiss it as, oh, he's just gonna check for completion or whatnot. Alright, so coming back from the fire drill. Here we go. Now, listen, I'm not coming down on you. That's not what's happening right now. I'm just trying to communicate that this will start being updated big time, okay? So the organization of that just went skyrocket up. And the reason of that, and that's my bad, I'll take responsibility on that, is because before, like if I assigned homework, or if I forgot to assign homework or wasn't clear with something, I always got all these texts, right? Of, wait, what are we supposed to be doing, or when is this due and what out? That kind of happened with this stuff here, but I did communicate, check the calendar, it is posted, and I didn't really get these texts. So to me, I thought you understood, okay, we're good, just check the calendar and we'll just do everything like that. But because you necessarily haven't been conditioned to depend on this calendar, and that is my bad, I think that's why a lot of people weren't ready to turn in this homework today, okay? So going forward, I will fix that, okay, and I ask that you do the same. Read the calendar like crazy. Okay, the calendar will tell you everything. Even if a date needs to change, which now it has, you're after B-Day, if you can tell, it'll reflect that, okay? So you have a flip grid due tonight. Real quick, if you clicked on these links, it'll take you straight to flip grid links and whatnot. Read it carefully, please, okay? Read it very thoroughly. Don't just necessarily try to take your own interpretation of what I'm asking you to do, okay? Read it carefully. It will all be there. It is due tonight. Again, those of you who have been absent for whatever reasons, tournaments, softball's coming up, baseball's coming up, all kinds of things, wrestling, whatever you're absent, please be diligent, as I will be more diligent of putting on what you missed video-wise. So this worksheet, yes, please print this off at home and then turn it in. Again, it was due today. If you want to turn it in for 10 more points, you can for today. If not, just do it over the weekend. This homework is no joke. There's no joke. Like, this is, if you need to go watch that video again, please do so. But please make sure that not to blow out this homework for sure. Because second Second fundamental theorem is huge, okay? The flip grid that you do here, some of you are struggling with homework grades. You know what I mean? Some of you might have struggled with this quiz that you're going to get back today. You can't blow these flip grids off. You can't. You have to do this flip grids. I think the first one, there were 4 or 5 people that didn't even do it. Okay? So that's a 0 in the grade book. I'm going to be a lot more accountable on myself with these dates, and I ask you to do the same. If it says turned in on the 24th, then the next class is a 70. The next class is a 0, no ifs, ands, or buts. Okay? Not, well, can you please? Okay, please make sure that we're pushing for that. The reason why I say that I want to up this big time, both for you and me, is because the quizzes were a little rough. Okay, I think they were probably 5 to 7 points rough than what I expected, and maybe than what you expected. But it's all good, because it's just a quiz. We fix, we clean, we move on, we move forward, we build, we refine, even get better, because the test will change your grade drastically the opposite direction. Okay? And the test is definitely a big test, if you've already noticed. This is a huge unit. It's not, it is one of the biggest units all year. Okay, a lot of information. So what we're going to start today is day 6 and 7. We have 2 days basically, and there's even one more day, I think it's on day 9, to where we're going to be dealing with something called U substitution. It's not difficult. I think my color coordinating in my highlighter is going to help you tremendously. I'm going to use some Mountain Dew to help out too, and you'll see what I mean by that here in just a bit. Any questions? Okay. Flip grids, please, please, please do not blow them off. Look for them as far as their due dates, so on and so forth accordingly. Please do your web assign. Oh, the one Delta Math that had those summations, if I put in a 0, and I understand that I have to show you that summation from me rather than a silent video, I don't mind giving you full credit for that, but that needs to be done by the next time I see you. Okay, that's it. Everything else, the dust has settled and we're back in our groove. Okay, any questions? I will give you the quiz back today. I do want to give it to you so that you can keep. You do not have to give it back to me. Cool? And Kevin, of course, I trust. But today during Eagle time, okay? All right, here we go. So let's look at U substitution. And the internet is, I apologize that the internet is messed up right now. I would say it doesn't matter. You don't need to necessarily have the printed notes packet. I think, and I'm not kidding this, with U sub, you need to write it all out. You need to see every single example, okay? So if you're one of those people that likes to sit back, kind of relax, and kind of learn it by watching, that's all good. But once you've learned it, you need to start writing, whether you're that way or not. You need to start writing like the 3rd or 4th example in your notes, because they do get more progressively involved. Not difficult, just more involved. All right, here we go. U substitution is what it's all about. All right, here we go. And yes, bonus points are still active. Great questions and even great answers will give you points. Before you start this problem, we covered something in our notes previously that was a very, very important thing that says why we have to do U substitution. And it was this right here. What does that mean? What am I saying? Say it out loud. Okay, I heard a lot of stuff, but I didn't hear the actual terms of there's no such thing as an antiderivative reverse product rule. Did you say it? Okay, so a reverse product rule, there's no such thing. Because of that, we need U substitution. Okay? No reverse product rule, we need U substitution. With that being said, the next question is, how do you know when to use U substitution? How do you know when to use U substitution? When we use chain rule, and that's what I was wanting to hear. when we use multiplication, how many terms do you see? One. Here we go. It looks like there's more than one term, but there's only one because it's all glued together by multiplication. Okay? Here we go. So what we're trying to do is we're trying to substitute x's with u's. Our goal is to make this ugly mess easy to understand. Easy to understand. So, identifiable, multiplication, multiplicative one terms, look for those. Okay? Look for the multiplicative one terms. The second thing is the power of parentheses and the rewrite. If you understand this, you will make these problems so easy. Okay? For you to understand that, you need to figure out what is parenthesized and what is not. Okay? Here we go. Our parent functions are x squared, square root of x, 1 over x, natural log of x, e to the x. You see where I'm going with all this? The power of parentheses. Now, I know it's not required, but back in my day, we needed to actually put parentheses around a denominator. Because we didn't have something like 1 over x minus 3 like y'all have in those fancy calculators these days. We actually had to do 1 divided by x minus 3 with the power of parentheses. You with me? Are we good? And what I'm trying to show you is these parentheses are going to be your u. Okay? So these are going to be your u that you're trying to establish in your steps. You're trying to find what is u equal. Okay? Because Mountain Dew will help me. When I find du, Mountain Dew is green, right? Yeah. So I'm going to use everywhere where du should go. That's what I'm going to replace with this green. Are we good? And you'll see it here in just a bit. All right. So I have, how many parentheses do you see? I see 2. Go for the bigger parentheses. So we're going to say, let u equal x squared plus 1.
Is it bigger in terms of size or power?
It's bigger in terms of power. Excellent question. Excellent question. It's not how many terms it has. It's more so, what's the power? Yes?
Is it inside or outside? Power inside or outside?
The power, I see what you're saying. The power both inside and outside.
So like the first one would be 7.
So the first one's actually 10.
Oh, yeah.
Okay? But we're looking at both, and you'll see why. Let me get to that step, but that's a really, really good question. It's all about the power and what we see. Okay? Here we go. So u, I'm going to use orange for u. Are we good? So if I were to rewrite the original, it's as if I have the integral of u to the 5th going on right now. Y'all see what I just did? All I did was establish u as x squared plus 1, and I rewrote it in my original exactly where x plus 1 used to be. Okay. So underneath, I'm going to write in black, but I'm going to highlight in green. I'm going to do the do part. Okay, here we go. This is the derivative of u is du, like a differential. Think of related rates, dy dt. Remember that stuff? Okay, here we go. So we're just going to take the differential. We're not going to do, say, du dx.
Teachers, pardon this interruption.
Okay. So now, the derivative of u is du. If I asked you from that pattern what the derivative of x squared plus 1 is, what would the derivative of x squared be? 2x dx. Okay? It feels like that implicit differentiation, that dy dt kind of stuff. Okay? So let's go ahead and write that out. So this is 2x dx. Guys, if you forget this dx, it's 1 point off your test every time you forget where you're supposed to put it. Okay? Now, here's the thing. If this right here is 2x dx, my question is, do you see the Mountain Dew? Ooh, I don't want to do too much. I do too much. Anyway, so 2x dx, can I find it in my original equation? Yeah, it's smiling right there. So I'm going to replace that, aka substitute that with what? Du. Look at that. That mess we just made into u to the 5th integrate. And it requires a handful of problems for sure to, oh, that's what we're doing. Then it requires a lot more to do the difficult ones. Okay, here we go. What is the integral of u to the 5th? U to the 6 over 6 plus c. If you wrote this on your test, it would almost be fully correct. Because you were asked in terms of x, you need to answer in terms of x. So you just put what you established, what you deemed as u, you're just going to put it back in. So it'll be x squared plus 1 to the power of 6 all over 6 plus c. That's good enough for me. And you can leave it like that. We good?
So du, is that just taking the integral of the derivative, so it just kind of cancels out?
No. So you'll see here in just a bit, okay? It's not the integral, it's not like second fundamental theorem where it's the derivative of the integral. It's just writing it in a different language. Here, let's just give the example. X, we could say, is English, but it was too hard to understand. So I translated it, let's say, to Spanish. Or maybe I should have done that backwards because we speak more English. Anyway, you know what I'm saying? We will translate it to a different language so that we can integrate the understandable integral. Like the integrand is, we can understand that. It's just u to the 6 over 6. And then last but not least, we want to Google translate it back to x.
So what happened to the du?
Oh, okay, I see this question. Now I understand. It's an excellent question. So du, the reason why I'm giving him 200 points for that question is because if you forget to write this dx, I'll take off a point every single time. If you forget to write this du, I'll take a point off every single time. And he's asking, what happened to the du after you anti-derived? It disappeared. Let me show you why. If I told you to derive y, let's go back to like first semester when things were much easier. And I said derive y, what would you say by default? Y prime or dy dx. So when you derived, bless you, magically this dx appeared to show you just derived. When you integrate, this tells you what you're in respect to. Okay? It tells you the variable that you're in respect to. When you anti-derive, magically it disappears and it goes back to when it when it wasn't there.
Okay.
Does that make sense?
Yeah.
We good? Okay. Now I'm going to work on very, very clear work, starting from the second example of exactly what I'm talking about, how I want you to write everything. And it has to be to that detail, okay? Here we go. Thank you. I look at this, and I see a bunch of terms all glued together as one with what? Multiplication. And it screams out to me, it's probably U substitution. So I now need to think of my parent functions or find the quote-unquote biggest parentheses and make that U. Okay, here we go. What's my biggest parentheses? 2x cubed plus 5. Not 2x cubed plus 5 to the power of 4. Don't include the power. It's just the parenthetic piece. So here we go. 2x cubed plus 5. If we chose correctly, which I'll be honest, sometimes you may not choose correctly. You build that experience and knowledge. If I chose correctly, then it will pick up all the scraps in my original integrand. Okay, and this is what I'm talking about. My original integrand right now could be rewritten as u to the 4th. So I'll put u in blue, and it looks like this right now. That's the only thing that we have accounted for. Where we used to see all of this 2x plus 5, I'm now just going to put u. We still have to account for the x squared dx. You with me? So that everything is translated. Here we go. The way we do that is the differential. Take the derivative of both sides. The derivative of u is du. What's the derivative of the right? 6x squared dx. Force yourself to say the dx or you will lose those points. 6x squared dx. Okay, here we go. Here, I'm going to use green for Mountain Dew. Here we go. I need to pick up, whoa, too much Mountain Dew. I need to pick up the x squared and the dx, which I just did. But where did this 6 come from? Well, it came from doing the differential of u. And watch how I fix that. Dividing both sides by 6, now in my original problem where I used to have x squared dx, guess what I'm going to now write over here in my newly built integral. 1/6 du. Now I can write the du here, I can write the 1/6 here, but guess where I'm going to end up writing that 1/6? Outside because of constant multiple rule. This right here is why I said constant multiple rules, it's the most important thing. Yes?
I still don't understand why you pull the 6 out, because there's no 6 in the original equation.
So, with there not being a 6 in the original equation, here's what I ask. Is there an x squared dx in the original equation? Yeah, right here, right?
Yeah.
So now, if I divide both sides by 6, which you can do that because it's an equation. You can do whatever you want to both sides of an equation as long as you do it to the other side.
So why 6? Why don't you just pull it out like we did with the first equation?
Because we're not doing constant multiple rule yet. Okay, all we're saying is when we divide by 6, this cancels to become what's recognizable up here in the original equation.
I know, but why did we multiply it by 6 in the first place? Like why did
Oh, why did the 6 even appear?
Yeah.
Because we did the derivative of this. The derivative of 2x cubed became 6x squared dx.
Why?
Because we're deriving both sides from this to that level. Those are the steps.
Oh, okay.
Yeah.
Okay.
Don't,
And then,
that's a big step.
oh, and that's how we got the 2x in the first
Yeah.
place. I thought we just pulled it out of the equation because it was already there.
No. Yeah, no, that's a big thing. I'm not even kidding you. That's a big thing because I struggle with that too. Did I just find the derivative piece, or did I just find the y piece, or you know what I mean, the function piece? It is kind of to understand that. That's a big step for sure. It is a big step. All right, let's go to integrate. U to the 4th, easy cake. U to the 5th over 5. Dylan, what happened to that du?
Just disappear.
By how?
Because you're integrating what you derive appears.
AKA magic. Okay. Yes. Yes. Thank you. So, and then we're going to multiply by 1/6. Please don't think that's 1 over 65. And then plus c. All I need to do to get full credit is to make sure that we resubstitute what we deemed as u. And I would want you to actually write that 30. Because that's easy. Questions? Yes, please. You will not annoy me with questions. I don't want to grade another quiz because I ran out of ink, okay, with red. So I'm just saying, I don't want to grade another quiz. I'd rather answer all these questions right now.
So is the plus c just because we don't have
Perfect.
A
The
and B?
plus c is because it's an indefinite integral. Cool. All right, so let's start doing, because they do get more involved, guys. I just want to make sure that you understand, and I'm just joking about the red pen. Here we go. Partially. All right. I see a huge term glued together with multiplication. To find my biggest parentheses piece, I start thinking about parent functions. And the one that's screaming to me is this square root.
Wouldn't it be the x?
Okay, so here's what I say. I have two functions that are parent functions right now. I have this, and I have this. Back in my day, I'll say again, whenever I would put a square root symbol, automatically, first of all, I wasn't even that fancy. It did like just very little. But automatically, the calculator would spit one of those out. And the reason why it did is whatever I typed after, I had to finish it with that. You with me? So this whole radicand is a nice little packaged parentheses waiting for me to use. Okay? It's screaming at me, telling me, hey dude, u is probably that. Y'all understand what I'm saying with that analogy? It's with identifying parentheses inside of parent functions. I want you to find that because they get harder than this if you don't know your parent functions. And it's not because of the calculus, it's because algebra 2 parent functions. Okay?
And you would still do that even though the power is technically less than the
Yep, yeah. Even though the power is less than 1, and I see what you were saying, you were going off of what Nathaniel was saying earlier, it's more so the parent function trumped that power.
Okay.
The bigger parentheses, parent function wise, is screaming at me.
Alright.
And the reason why that is screaming at me, check this out, is when I take the derivative, what's the derivative of the right side, everyone? 2x dx. I'm looking for these scraps in the original one. Well, there's one of them. There's another. So right now, all of this is u. And the x dx, it's been accounted for. The only thing that I need to change, and I was one who required this last step for me to fully understand. I needed it. I needed to go all the way to 1/2 du and know that everywhere in the original equation, and we didn't have color highlighters. Can you imagine the frustration? But everywhere in the original one where x dx used to be, I'm now going to put what? 1/2 du. Constant multiple rule. I'm going to save myself a little bit of time by immediately pulling out that 1/2. constant multiple row y's. I know it's now du, and I'm going to put the square root of what? U. Raise your hand if you feel very confident with what we've done so far. That's awesome. That's awesome. And I think it's because of colors, believe it or not. And Mountain Dew. So here we go. So this is going to be u to the power of 1/2. We're putting all of our skills together. The power of the rewrite. Notice that I only integrate the integrand, this stuff right here, first. Then at the very end, I'll multiply everything by the constant. Okay? So u to the 1/2 becomes u to the 3/2, 2/3. Multiply, plus c. Now someone asked me this question before. If you multiply 1/2, don't you technically have 1/2 c? Well, here's what I said. What's 1/2 of a constant? It's still a constant, right? So you're still going to just put plus c. So this will be, those ones cancel, and you're left with u, which is my original u that I assigned, to the power of 3/2 all over 3 plus c.
Would you rather us write 3/2 or like
I would rather you write fractional exponents. Instead of the square root of x squared plus this, remember, the power is the numerator, and the understood root, which sometimes could be 3, 5, 8, whatever, when nothing's written, is understood to be 2. We good? Alright. We're going to do bonus points here in just a bit. I just want to make sure everyone is equipped so that you can do the harder ones. Okay? Now look, before we move on to the next one, what if I said u was x? What would du be? No? Dx. So that means where I used to see a dx in the original, I'm now going to put a du. Where I used to see an x in the original, I'm now going to put what? U. That means here too. That didn't do anything. You see what I'm saying? Because what we want, okay, this is huge what I'm about to say. Why did that not do anything? Obviously because it's just a letter with a letter. But what is that revolving around? What is it that we need to concentrate to make the U substitution happen? Wait, what? Composite functions. Yeah, composite functions. Compositions. He's exactly right. That's big. That's huge right there. Okay? So composite functions is what you need. Because if you can find the composite functions, all these scraps, they'll pick up. Okay? We good? Right now we're probably about level 3 to 4 with integrals. We still have to go all the way to 10. Okay? Yeah, so I need you to really understand all these pieces. Yeah.
So does this work where you can just set up a random equation, take the biggest parentheses, and it'll pick up all the scraps, or are every problem?
See, this is why I just said that 3 or 4. There's some integrals that you will not be able to use some of the things that we do. You're going to have to use other things that you learn, like in Calc 2 or BC Calc. You won't experience those here. I mean, I will expose them to you, so you'll be like, oh, yeah, we can't do that with this. But you won't be tested. You won't be tested on that. You know what I mean?
So every problem, it's going to pick up the scraps. Okay.
For this. Yes. But there's a lot of integrals that you have to know. Because remember, there's a lot of derivatives we learn. Like, let me ask you, I'm curious if you know. What's the derivative of arctangent of x? 1 over 1 plus x squared, right? So all those rules that we remember from derivatives, we're now going to be thrown at with integrals, but with U substitution as our little sidekick, as our little helper right here that's going to help us be able to answer these if we knew the derivatives first semester. Cool? Because if we don't know the derivatives, we're never going to be able to get that.
Yeah.
Make sense? All right, yes.
Is this the only like weird one where it's not the biggest power?
Well, not the only one. It's more so, and I probably shouldn't have answered that the way I did. I don't necessarily just only want you going for the biggest power. 8 out of 10 times, yes, it'll work. But sometimes it's more what is a more cumulative piece? Like, here's an example. Let's say some of y'all's rooms are messy right now, right? If we were to go to some of your rooms, like there's laundry everywhere. Your mom's like, man, pick up your laundry, whatever. My mom used to do that to me all the time. Anyway, so there was a small laundry basket that my mom gave me, right? Small laundry basket. It took me forever because I'd have to go put them in the community laundry basket and back and forth. And I would just go to her room and grab the big basket. So then I'd come to my room and I'd grab as many shirts and whatever that I was putting so I could grab the most thing in one trip, and bam, there's my laundry, Mom. Please do it. Okay? So I had to say the please. But my point is, the bigger the laundry basket, aka the bigger the parentheses, the more you're going to pick up. Okay? And that's weird, but I even thought about all that stuff when I was learning this. Like, how can I visualize if it's the power or the parentheses piece? You see what I'm saying? And it's kind of both. But as you practice and experience, you'll see it.
So would you say whichever set of parentheses is the most successful?
To me, I think the parentheses are important. I think the power is my first go-to. And then my parentheses, parent function-wise, is my second go-to. Okay?
The power inside the parentheses or the power outside?
It's the power outside of the parentheses.
Because like the square root is just like...
No, I know. The
power
square root is 1/2.
one half.
I know that. So I know that this is 1/2, and I know that this is 1. But at the same time, with parent functions, think of more laundry pieces of laundry. I'm picking up more if I say U is the stuff in here. You see what I'm saying? Like, look, if I had this versus this, I would want U to be this. But as soon as I have more pieces of laundry and articles of clothing, aka the magic word is more terms, then that's my U. Even though the power is smaller, that's my U. You with me? Even if this was x squared and stuff like that, or x cubed, I'm going to gravitate more to that because it can pick up scraps. Yes?
So they're both like really, really similar, and we can't really tell which one should be you. Should we
So-
just try both?
Yeah. And that's the thing is, you're going to learn, you're going to see through all the examples. I'm going to start picking up the pace because now you know the steps. Now we just got to see which one works and which one doesn't, when and where and why. Okay? Here we go.
Is there any situation where both work?
There's not, well, yes, there's a situation where both work, but do you want to do something the most efficient way, or do you want to just get it done? You know what I mean? I want to do both. So, through experience, you'll see that.
I was gonna say. Okay, so what if there's like two terms, and one of them is like parentheses 2x squared plus, I don't know, whatever, 3, and then it's like plus or multiplied by,
Oh, we're getting to that. I know what he's saying right now.
yeah. So
Watch this here in just a bit, okay? Look, we're not there yet, but wait for that, okay? I'll tell you, we'll come back to it. All right, here we go. What parent functions do you see? Square root of x. Ooh, who said that? I also see 1 over x. Okay? So, compositions, right? That's why you got 300 points for that realization. So, 1 over x I see. I see x and I see square root of x. I see many parent functions. But those are the primary ones that I see. You with me? Okay. So here's a hint. When you see a fraction and you experience this parent function, chances are everything in the denominator is probably going to be your u. Okay, don't write this down yet. Don't write this down. That means if everything in the denominator is probably u, then I'm about to do the derivative of that. What? That 1/2 makes it, ooh, nasty. That makes it, so you don't want to do necessarily chain rule in your little du piece. You don't want to do no chain rule. So that was horrible grammar. But anyway, so if I derive this, it's going to be easier. Watch. What would du be? 6x dx. Now watch. The rewrite on the original is the square root of u on the bottom, which we're going to rewrite as u to the negative 1/2. You see what I'm saying? That's why you don't want to bring that power. Don't do chain rule inside of your u assignment. If you do, you're doing way too much work. I promise you. I hope you all heard that, because when you do your web assign, if you didn't just hear that, you're going to run into a lot of roadblocks and you're like, oh my gosh, why won't this work? To me, it will work as long as the power is 1. If the power is 1 of the denominator, then make the whole denominator your u. If it isn't 1, do what we just did just now. And that works with a lot of other things. If it's not 1, make it 1 and stuff like that. Okay? Okay, here we go. So, I saw my u assignment made this square root of u appear. Mountain Dew. This is my dew. But not technically my dew. 1/6 of my dew will replace x dx. Y'all see it? So when I rewrite this, okay, it will be 1/6 what? Du. Now look. This is much easier. If you ever get a du in your denominator, you've done something wrong. Because this is the same as that. Du should be over 1, aka it should be in the numerator if you're visualizing it as multiplication. Okay? So then this will become 1/6 u to the negative 1/2 du. Easy to integrate that. So it becomes u to the 1/2 times 2 over 1 times 1/6 plus c. You can use the square root. I prefer fractional exponents. The 2 and 6 would reduce to 3 in the denominator. Then you're left with u square rooted and you could write it underneath the square root. There's your answer. If you derived your answer, you would get this original integrand. Cool? Okay. Let's start picking up the pace a little bit so that we can get to the harder ones. Okay, here we go. What's u? 3x. What's du? 3dx. I don't see a 3 as a coefficient up here in the original. And as you get better, you won't have to do this last step that I just did. Mountain Dew, right? That's going to become 1/3 du. My u assignment was 3x. So the u assignment was the orange. The Mountain Dew pickup was there. Cool? Should call this Mountain Dew substitution. You have a question?
We still
Okay.
have to plug in the 3.
Okay. Oh, there we go. There's a good mistake to make, and a nice pickup recovery that he earned points for answering as he was hearing that question. So, you need to integrate first, because nothing has happened. Only rewrite and substitution has happened. The magic hasn't happened yet. We haven't made that du disappear. Okay? Everyone, what's the integral of cosine? Okay, sine of what? U. Sine of u, 1/3. And yes, technically it's 1/3 like this, but again, I don't want you thinking that, because 1/3 of c is still c. Okay? And only now you're going to replace it back with what you assigned. And yes, if you took the derivative, you would get the original integrand.
So this is probably a really stupid question, but I just remember when we were learning like chain rule and everything, the formula sheets that we learned always used u as the variable. And I'm just thinking about that with this. Like, does it have anything to do with that? Like the reason why they're both u? Or is it just like coincidence?
Here's what the thing is that it does, because you know how when we do from here to here, it's like we're deriving in respect to x. You see what I'm saying? So everything is du dx, but nonetheless, it feels like this composite chain rule that we were doing. That's what u is expressing, that composite chain rule.
Okay.
That's why they used u for use. But they could have used any
Yeah.
substitution. You know, they could have been smiley face substitution or whatever, theta substitution. It's just a variable.
Okay.
Who can answer this question though? Because this is actually I just realized this is a big question. Why is it u on some of them and x on the other? One is assuming something and the other one's not.
If it has u, it's like you're just.
This is big and we're about to do it.
Oh, I'm not sure.
No, it's okay if you're not sure. I want to hear what you are thinking.
I was gonna say like on a calculator you can graph with x, but like
Okay, so calculator you can graph with x, but you can't with u?
well
A little bit. I see what you're saying, but it's not necessarily that.
I think it's just like showing you're not doing it, because in terms of x, you have to bring it back to x, but like you're doing your work in u, so you don't get confused.
That is all correct, but that's not what I was going for as far as why do they use u and x?
If it has u, you're assuming that there's some function in place there that like.
Okay, yeah, keep
you're
going.
assuming that it's the biggest parentheses.
Keep going. But if it's
Exactly.
x,
And if it's x, then it's just, it doesn't matter if it's the biggest parentheses. Yeah, it's just a variable.
X isn't a function.
that's not what I'm going for. You were almost there.
Is it that when it's x, you're assuming that nothing's happened yet?
She's closer.
Like in u, you're actually like doing it.
And I want you all thinking this. That's why I haven't told it to you yet. I want you processing this in your head. Because it will make all those 10s become 5s. All those 8s become 3s, and so on and so forth. That's why I'm trying to help you out right now by giving you time to process this. Here we go. Because with u, the coefficient is not understood as a positive 1. With x, all the coefficients are understood as a positive 1. If it's not positive 1, it's u, which is composite functions. It has more than just positive 1 with chain rule interpretation. Do you understand? So our goal ultimately is to make it 1. And you'll see what I'm talking about for those 8s and 9s and 10s and stuff. Okay? Here we go. Alright. So I see. Okay, let me ask you this. What two main parent functions do you see? X squared and secant of x. Let me show you why. The power of the rewrite. Do you see how you have, look, if you said x squared because of this, that's awesome. If you said x squared because of that, that's even way more awesome. Okay? Or it's secant of x. Go with me? Different parent functions that you see. Here we go. Let's go for the biggest parenthetic piece that we can possibly find. Secant x cubed. Oh, ooh. Thank you. I would have been bad. Alright, so let's go for the biggest u that you've learned so far. Okay, here we go. Don't write this down yet. That means it's not going to work. Alright, so secant of x cubed looks like our biggest parentheses. But if I derive this, look, right here, x cubed is not just 1. It's not just 1x. So when we derive, it's got to be secant tangent, I know, right? Times whoa, where did all this laundry come from, right? This wasn't in the original problem. So I chose poorly, no worries, I grew around and I learned from it. Sometimes the biggest parentheses, rarely, but sometimes the parentheses that's the biggest, quote unquote, is not necessarily the correct one I should have chosen. Okay? Here we go. And this, what we just did, would be the same as if you chose u on the other problem as all your denominator to the 1/2. Your brain will hurt, okay? And that means you chose poorly. All right. So, if secant of x cubed didn't work, what do you think should be x cubed? X cubed. Here we go. So x cubed du is 3x squared dx. Otherwise, yep, I would have done that too. 1/3 du is x squared dx. And to me, the Mountain Dew, right? It helps me identify the scraps of laundry that were just picked up from my U assignment.
Could you like just from the beginning look at the function and
Yeah.
say which thing will get you the scrap
Yeah.
part?
Some of you are already seen it. Some of you can see the original now from all the practice we just done for the last, 4 or 5 problems, and you can see it already. If you can, it's because your derivatives are just fast. You know what I mean? People whose derivatives are not that fast, they won't see it as fast. That's why I'm trying to give them a methodical process to catch up. Not only relearn all those derivatives that they should know right now, but, you know what I'm saying? To have a good safeguard to still go through and still be able to master the use of.
What was that, derivatives chart for like secants and tangents and cosecants and whatever?
It was useful for this because look, the rewrite is 1/3 du, okay? And what I just did was I just picked up, whoa, not that color. I just picked up this stuff, okay? And then over here, the secant squared, I don't necessarily have to write it in parentheses if I'm knowledgeable with my derivatives and integrals, right? What's the integral of secant squared? Tangent. And why was it so easy right there? No, okay, yeah. But I'm saying, but why was it so easy right there, but it wasn't before with the sec, like, you know what I mean? Like, let me ask you this. It was easy for you to say tangent of what? U. Technically, 1/3 tangent of u plus c.
Right.
Had I written this, why is this not as easy to do as secant of u was? Because, yeah, the composite chain rule, the coefficient of u is 1. And when it's 1, we are happy, right? But if it's not 1, we need to do u substitution.
But the little chart that you had that taught us back in derivatives, it's secant, secant, tangent, cosecant, cosecant, cotangent, right?
Yeah, that was for the derivatives. Yeah,
Yeah, I'm just.
it was secant, secant, tangent, and it was cosecant, cosecant, cotangent. Yes.
Oh, I was just gonna ask, do you ever have to like do u substitution like twice in the same
Oh, girl. Yes. So you will have to do u sub sometimes 2 or 3 times. That's what I know, man. No, it's not why it's you. But like you would do it 2 or 3 times to get your final answer. And that's what makes the 8s to 10s happen. But hey, I'll tell you right now, 8 to 10s, 8 to 10s, 8 to 10s and AB calculus are nothing compared to the 15s to 20s that you experience in BC Calc. Okay? So, and listen, those are, I don't want to scare you, those are not really that bad. That's not a 15 or 20. That's more like an 8 in BC Calc. Okay? But the 15 and 20s, look at Anadi. Alright. Alright, let's finish this up though, because we're not done. So, 1/3 the tangent of x cubed plus c is our answer. Now listen, this is important. This is huge what I'm about to say. When you're given an indefinite integral, you always have plus c, right? Okay. If I ask you to give me the answer, and it's originally stated in x with an indefinite integral, you have to give me x in the final answer. When we do a definite integral, which doesn't give you a function, it gives you a quantitative constant answer, you don't have to go all the way back to x. You can stay in Spanish, you can stay in u, and finish it with u, and it goes super fast. In fact, if you go back to x, it makes more work for you. We might see some of that today. I want to get to his question, okay? All right, so let's go. So I'm gonna start you off with the setup. You can integrate the rest, but I want to help you with your homework. What would the u for this one be? A lot of us go to 5x immediately. Check it out. If I wrote it like this, does your 5x still stay in your brain? Here's what I'll say. If you know your derivatives fast enough, you should actually be this. Because, again, I'm trying to pick up those scraps. You get cosine of 5x, ding, 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 ding. It's right there, it's right there, it's right, you know what I mean? Times 5, because chain rule, we got to multiply by the derivative of the cream. We're eating Oreo cookies still. And then dx. You with me? So that the rewrite becomes 1/5. You help me out from here now. 1/5 of what? I got to do colors because I'm the same way, guys. Some of you, I'm like, so I can see on your face, you're like, do the colors. All right, so this is u cubed, right? And then what? Du, because look, the du is 1/5 du is all of this that just got picked up. Okay, so, oh, green. All of this is now right there. I hope these colors help. And I didn't even think of Mountain Dew until yesterday when Mr. O'Brien was doing it to his class. I'm like, Someone said, do the Dew, man. But anyway, I was like, green, Mountain Dew, I'll just use that. Okay? I think it helps. I hope it helps. Don't drink Mountain Dew, though. It's bad for you. Anyway, so what's u cubed integrated? U to the fourth over 4
Plus C.
times 1/5 plus c. So it's u to the fourth, notice my writing, over 20, done. This is, believe it or not, probably like a 5 or 7. If you can see it, then you're good. Okay, now let's move on to, I'll set up this one, but I won't finish it because I want to get to Caleb's question. Here we go. I have cosine of x squared. I have sine. Don't be afraid. If you make a mistake, you'll learn, I promise. Take a chance and tell me, what do you think u should be? Cosine of x squared. Okay, let's watch. Let's watch the scraps get picked up. If u is this, then du, negative sine of x squared, don't do that yet, negative sine of x squared times 2x times dx. If you need to go back and watch that video, the order that we're doing this stuff, go for it, okay? Look at all that got picked up. And now I'm no longer going to write those intermediate steps that I was writing before. Look at all that just got picked up. All this Mountain Dew just got accounted for. So it'd be negative 1/2 du and u to the what? 4th. And you can finish it off in there. Good?
Oh, you wouldn't use like u to be like sine of x squared?
So here's the thing. That's a really good question, because he's like, what if I used sine instead of cosine, because they both have x squared, right?
But
then you don't get rid of it.
yeah, then
You don't get rid of certain things, but sometimes even if you do, the negative mistakes that happen are just horrendous. You know what I mean?
Yeah.
They're just like, oh my gosh, how did I miss that one little negative? And I know you've all experienced that in your brain at least once this whole year. If you do the wrong assignment, you experience more negative mistakes. Okay, let's go to see if I can find it. Oh. No, you don't need it there. I'm going more for, I'll find it. It's close. I feel it. Feel it.
So are we gonna have definite ones on our board?
You will not have, in case you do, I can give you 2 more examples before you leave, okay? 2 more examples. First of all, let's do a definite integral of what was just mentioned. Thank you. I'll give you points in a bit. But also we're going to do Caleb's idea of this question. Okay. Let's do, okay, I'll make one up. Alright, so his question, it's not that. His question, what the heck? His question is involving this right here. I believe. Now look.
Whoa.
Watch out for the air.
Anyway, so I tripped on air. So you, at first glance, most likely, what would y'all say? X squared plus 1. You see it screaming at you. Now, Believe it or not, and you'll see some of these, I didn't create the perfect one to have you buy into what I'm about to show you, but I promise you'll experience this. Sometimes it's easier to distribute this. Oops. And then distribute that because you just have 3 reverse power rules.
Oh.
Forgot the last
Fair.
it's the second one.
Oh, girl, you want those points. So, right?
But yeah.
Do y'all see that?
Yeah.
Sometimes it's easier just to distribute and then make a bunch of reverse power rules. To me, if that power up here is 3 or more, I'm using U sub. I'm not going to do that foiling, because then you do Pascal's triangle, remember? So that's actually cool. We're actually learning it right now in Algebra 2. I think it's cool, but we don't have time for that. I think U sub is better.
That's for 2.
Yeah.
That's crazy.
All right, so let's go to Luke's question. Okay, here we go. And then this is our last one for the day. Okay. Awesome job today, guys. Seriously, awesome job. Questions, really, really good questions. Let's go with, since we were kind of doing it already, let's do example number 1. From 0 to 1, x squared plus 1 cubed this time. But now we have the definite integral. Okay? What's u? X squared plus 1. What's du? 2x dx. So 1/2 du will replace x dx. Okay, so here we go. We are replacing, we're replacing the Mountain Dew piece from the original with 1/2 du. Here we go. So the rewrite is 1/2 du, and it's, wait, what? Oh, yeah, I'm not done yet. I usually do. Okay. Anyway, so u cubed, that was the learning moment. I'm not done yet. But I'm glad that you said the 0 to 1. 0 and 1 don't go there. No. This is the new stuff that I'm showing you because of the question. This one is in English. These bounds are x bounds.
Oh, so you can't do it with the U.
So we need to translate and plug these in for, come on, for x. We're going to plug in for x. So 0 squared is 0 plus 1 is 1. Our U bound became 1 because now we're in Spanish. We're in U language. You with me? That's just like, that's not Spanish. Okay, so now if I put 1 in x, 1 squared is 1 plus 1 is 2. And the reason why I say this is I want to show you 2 different ways. U cubed will be, there's no plus c, right? Because it's a definite integral. Okay? So this will become u to the 4th over 4 times 1/2. But it's 1 to 2. Now listen, I'm not going to multiply the 1/2 until the very end. Why? Because I know the power of the constant multiple rule. Okay? So it's technically going to be 1/2 times whatever I get from f of b minus f of a. So let's plug in 2. You with me? Which is 2 to the 4th over 4. Plug in 1, which is 1 to the 4th over 4. Which this is going to be what? 16 minus 1 is 15 fourths.
Oh, yeah.
Which equals 15 eighths because I multiplied it by 1/2. Guys, the way I waited to the very end to multiply by 1/2 tells me that I only have to deal with that 1/2 one time. Had I included it up here, I would have had to have dealt with it twice, unless I simplified to u to the 4th over 8. Hold on, just real quick. So now look, my integral was u to the 4th over 4 times 1/2, right? AKA u to the 4th over 8. If I were to replace that, u to the 4th over 8, and I replaced it back in X language, and I translated it back the way we did all these other examples, I would have to keep my original 0 to 1, and I would still get the same answer. But it's too much work. I could do that just with u, with just the, what would you rather do? Change these bounds and finish it off like that? Or change the bounds, change them back, and then resubstitute u just to get the same answer?
Because you can do it when you
Yeah.
find those bounds.
That's a lot of stuff for one Friday.
Yeah, it's
We're gonna get the quizzes back.
Oh yeah, let me give you your quizzes. And you can keep them. Alright, so nice job guys, your homework will be due. Please watch the calendar, read the calendar, be the calendar.